Hello, grade 11 learners! I am Teacher Ann and welcome to Telemath Aralan. This video was made to help you solve real-life problems involving rational functions. You will be introduced to different types of word problems and situations. These problems can be transformed into rational function. Your focus, patience, and determination will play an important role in dealing with these real-life problems. Moreover, you will also realize that rational functions can be applied in real life, strengthening your problem-solving and modeling experience. After watching this video, you will be able to solve real-life problems involving rational functions, how to analyze carefully and understand word problems before solving them, and create real-life word problems about rational functions. Let's get started! Did you know that to be able to solve rational functions, it is necessary to know the basics of algebra? Solving rational functions is very essential in solving word problems. Real problems like mixture, work, distance, number, and other related problems might interest you. If you are fond of observing your speed while driving, estimating your time while walking, analyzing your income while selling, determining the price increases and decreases, identifying rational relationships, and solving real-life problems, then this video is definitely for you to enjoy. Functions are used to model real-life problems. We shall now apply our knowledge of functions in solving problems. The following steps will be helpful in solving problems involving functions. 1. Read and comprehend the problem carefully. 2. Identify the function to use, if it's linear, quadratic, rational, and etc. 3. Write the function that describes the problem. 4. Use the function to solve the problem. 5. Check the answer. Let's study the following examples. Example 1. Motion problems. Motion problems are usually modeled by rational equations. When solving motion problems, we should recall that distance is equal to the product of the rate and time. In symbol, we have d equals r times t, where d equals distance, r equals rate, t equals time. Transforming the formula, we have also r equals d divided by t and t equals d divided by r. Let's have this problem. A sprinter runs 9 kilometers per hour faster than the other sprinter. When the faster sprinter traveled the distance of 93 kilometers, the one has gone 66 kilometers. What is the speed of both runners? Let's have step 1. Represent the unknown in the problem. Note that time is expressed as t equals d divided by r. Let x equals rate of the first sprinter. X plus 9 equals rate of the second sprinter. The first sprinter is slower than the second sprinter. The distance traveled by the first sprinter is 66. His rate is x. And to find the time of the first sprinter, time equals distance divided by rate equals 66 divided by x. The distance traveled by the second sprinter is 93. His rate is x plus 9 and he runs 9 km per hour faster than the first sprinter. That's why we added 9 to his rate. To find the time of the second sprinter, 93 divided by x plus 9. Step 2. Form the equation that describes the problem. The formula in finding the time is t equals distance over rate. Based on the problem, the function t equals 66 over x and t equals 93 all over x plus 9 are examples of a rational function because we are dividing a constant function y equals 66 by the linear function y equals x. And we are also dividing a constant function y equals 93 by the linear function y equals x plus 9. Since the time spent by both sprinters are equal, we can solve the value of x using rational equation. We have the equation 66 over x equals 93 all over x plus 9. Step 3. Solve the equation. Using the multiplication property of equality, multiply both sides by the LCD to eliminate the denominators. The LCD is x and x plus 9. Let's rewrite the equation. 66 over x equals 93 over x plus 9. Multiply both sides by x times x plus 9. X times x plus 9. Now, cancel out the common factors. X and x plus 9. X plus 9 times 66 equals 93 times x. Apply distributive law. X times 66 is 66x. 9 times 66 is 594 equals 93 times x is 93x. Let's combine like terms by applying subtraction property of equality. Let's subtract 66x on both sides of the equation. 66x plus 594 minus 66x equals 93x minus 66x. 66x minus 66x is 0. 594 equals 93x minus 66x is 27x. Apply division property of equality by dividing 27 on both sides of the equation. Divided by 27 and divide by 27. 594 divided by 27 is 22 equals 27x divided by 27 is x. X equals 22. Step 4. Check if the computed value satisfies the given condition. Let's substitute the value of our x to these two functions. Let's substitute first the value of x in this function. T equals 66 over x equals 66 over the value of x is 22 equals 66 divided by 22 is 3. T equals 3. T equals 93 all over x plus 9 equals 93 all over The value of x is 22. 22 plus 9 equals 93 all over 22 plus 9 is 31. T equals 93 divided by 31 is 3. So the value of two functions are equal. Then, the value of our x is correct. Let's have another example. A domestic ferry traveled for 222 kilometers when it moved along with the current, while it traveled 66 kilometers when it moved against the current in the same amount of time. Find the speed of the current if the rate of the ferry is 24 kilometers per hour. Step 1. Represent the unknown in the problem. Note that the time is expressed as time equals distance divided by rate. Now, let x equals rate of the current. 24 plus x equals rate of the ferry when traveling along with the current. 24 minus x equals rate of the ferry when traveling against the current. Step 2. Form the equation that describes the problem. Again, the formula in finding the time is t equals the distance over rate. The function t equals the distance of the ferry traveling along with the current is 222 and its rate is 24 plus x, and the time equals the distance of the ferry traveling against the current is 66 and its rate is 24 minus x. These two functions are examples of a rational function because we are dividing a constant function y equals 222 by the linear function y equals 24 plus x. And we are also dividing a constant function y equals 66 by the linear function y equals 24 minus x. Since the time spent in traveling along and against the current are equal, we can solve the value of x using rational equation. We have the equation 222 all over 24 plus x equals 66 all over 24 minus x. Step 3. Solve the equation. Let's rewrite first our equation. 222 all over 24 plus x equals 66 all over 24 minus x. Let's eliminate the denominators by applying the multiplication property of equality. Let's multiply both sides by the LCD. The quantity of 24 plus x times the quantity of 24 minus x. The quantity of 24 plus x times the quantity of 24 minus x. Now, let's cancel out the common factors. 24 plus x and 24 minus x. The quantity of 24 minus x times 222 equals 66 times the quantity of 24 plus x. Let's apply distributive law. 24 times 222 is 5,328. Negative x times 222 is negative 222x. equals, okay, again, apply the distributive law. 66 times 24 is 1,584. Next, 66 times x is positive 66x. Let's simplify using addition property of equality by adding 222x on both sides. 5,328 minus 222x plus 222x equals 1,584 plus 66x plus 222x. Negative 222x plus 222x is 0. 5,328 equals 1,584. 66x plus 222x is positive 288x. Now, let's simplify by applying subtraction property of equality. Let's subtract both sides by the value of 1,584. 5,328 minus 1,584 equals 1,584 minus 1,584 plus 288x. Now, simplify. 5,328 minus 1,584 is 3,744 equals 1,584 minus 1,584 is 0 plus 288x. Let's solve for x by applying the division property of equality. Let's divide 288 both sides. 3,744 divided by 288 is 13 equals 288x divided by 288 is x. The value of x is 13. Step 4. Check if the computed value satisfies the given condition. When the ferry is traveling along with the current, its distance is 222. Its rate is 24 plus x equals 24 plus 13 equals 37. To find the time, 222 all over 24 plus x equals 222 all over 24 plus 13 equals 222 all over 37 equals 6. Now, when the ferry traveled against the current, the distance is 66. The rate is 24 minus x equals 24 minus 13 equals 11. To find the time, 66 all over 24 minus x equals 66 all over 11 equals 6. That's all for this session. I hope that you enjoyed learning how to solve problems involving rational functions. I am Teacher Ann, and see you again here on Telemath Aralan. Bye!